Have you ever just stopped and wondered how an AI like ChatGPT actually gets what you're saying? Not just the words, but the real meaning behind them? Well, it's not magic, but it's close. It's a revolutionary piece of tech. And we're about to pop the hood on the engine that powers pretty much all of modern AI, the Transformer.
So this is really the core puzzle, right? For years, this was a massive roadblock for computers. Yeah, they could process words, but they just couldn't grasp context. How does an AI figure out that the cat sat on the mat means something completely different from the mat sat on the cat? The answer wasn't a small tweak. It was a groundbreaking new way of thinking that completely changed the game.
Okay, so to really understand why the Transformer was such a lightning strike, we first have to take a look at how things used to be done. Let's step into the old way of AI reading, a slow and very sequential world. I want you to imagine older AI models trying to read a sentence. They did it one word at a time. It's kind of like trying to appreciate a beautiful painting by looking at it through a tiny little straw. These older architectures, you might have heard of them, RNNs and LSTMs, they processed everything in a line. And that created a huge problem.
And here's exactly how that bottleneck would form. The model reads the first word, tries to hold it in its memory. Then it reads the second word, while desperately trying to remember the first. Then the third, trying to hold on to the first two. You can see where this is going. With every new word, the memory of the words way back at the beginning gets fuzzier and fuzzier. It just can't keep it all straight.
And that created this massive issue with something engineers call long-range dependencies. So imagine a pretty long sentence like, "The woman who lived in the house down the street, which was painted blue, sold her car." Now for you and me, knowing who her refers to is a piece of cake. But for that old sequential model, by the time it gets to the word her, it's probably already forgotten we were talking about the woman. It was almost impossible.
But then, a breakthrough. A moment that changed everything. Instead of squinting through that straw, AI learned to see the whole picture all at once.
And this right here, this is the absolute game changer. The Transformer architecture doesn't bother reading in a line. It gulps down the entire sentence, every single word at the exact same moment. It processes everything in parallel. That memory bottleneck we were just talking about, gone, completely eliminated.
So how in the world does it do that? It uses a mechanism that is basically an AI superpower. It's called self-attention. This is the heart and soul of the Transformer. It lets the model look at all the words in a sentence at the same time, and for every single word, it figures out how important every other word is to it. It instantly creates this rich, complex map of how everything connects.
So, Section 3. Let's look inside the Transformers toolkit. Because processing everything at once is, brilliant, but it creates a brand new and pretty obvious problem. So let's see how the Transformer cleverly solves it.
Yep, that's the one. If the model sees all the words jumbled together at once, how does it know the original order? I mean, the cat chased the dog has a very different meaning from the dog chased the cat. Thankfully, the designers of the Transformer came up with a really elegant solution.
The fix is called positional encoding. You can think of it like stamping every word with a little digital number before anything else happens. Each word gets a unique signal that says, hey, I'm in position 1, I'm in position 2, I'm in position 3, and so on. This way, the model gets all the benefits of seeing everything at once without losing the crucial information about word order and grammar.
And positional encoding is just one piece of a really sophisticated toolkit. The main idea here is that you have all these specialist components working together. For example, multi-head attention is like having a whole team of those self-attention mechanisms running at the same time, but each one is looking for different kinds of connections. Maybe one is tracking subjects and verbs, another is looking at pronouns and who they refer to. It's this whole team effort that lets the model learn the incredibly complex, nuanced patterns of our language.
All right, so we've seen the how. Now let's talk about the why. Why did this specific architecture become the absolute bedrock of modern AI? Well, the advantages are just massive.
So because the Transformer sees the whole sentence at once, it just crushes those long-range dependency problems we talked about earlier. And because it processes in parallel, not in a sequence, the training times are just ridiculously faster. It's that powerful combination,
better performance, and incredible speed that made the transformer the foundation for all of today's large language models, or LLMs, like ChatGPT and Gemini.
I mean, just look at this chart. The speed difference is absolutely staggering. Training those older models was a long, slow, painful grind. The parallel processing of the transformer just blows it out of the water. And this efficiency, it's not just a nice to have, it's the very thing that made it possible to build the gigantic, powerful AI models we use every single day.
When you boil it all down, it comes back to this one incredibly powerful idea: the ability to look at any part of the input at any time, all at once. That's the secret sauce. That's what gives the model its deep understanding of context, making it so much more effective than anything that came before it.
So let's be crystal clear here. This isn't just an option for building AI. Today, the transformer is the undisputed, hands-down #1. For basically every major language task you can think of, translation, summarization, text generation, this is the architecture powering the most advanced AI on the planet.
The transformer was a truly monumental leap. It completely redefined what we thought was possible with artificial intelligence. It solved this fundamental problem of context and sequence in a way that nobody had before. Which, of course, leaves us with one final, very exciting question to think about. What comes next?